Hello. Yeah, I think it's audible. Hello. Yeah, I think it's audible. Yeah. Okay. Sorry for the delay. Actually, there was power cut here. Okay. Now let's get started. So this is dices and cubes. Okay. So first we'll learn about dices. Now here, see. First of all, you must have seen dices, correct? Now, this one is the very famous one that you would have seen, that you play Ludo with. Okay, this is the one. So it shows 1, 2, 3 like this. Correct. So there are different numbers on different faces. This is dices. Correct. Now, apart from the numbers that you see here, 1, 2, 3, 4, 5, instead of this, what you can also have is any other thing. Ultimately, you have to fill the 6 faces with something. Correct. Now that may be 1, 2, 3, 4, 5, 6. That may be A, B, C, D, E, F, G, H, E, F. Okay, till 6. So basically, this is how you fill it. Now, in some questions of UPSC, you'll see that they are using some different kinds of symbols here. That also works. Ultimately, you have to fill the 6 faces with different something. Understood? Now, yes, Nandini, good afternoon. Now, a typical question from this dices looks like this. So basically, if this is a dice, now of the same dice, they will show you multiple images from different angles. For example, if this is a dice, I take one picture from the back, one picture from the front, one picture from the side, right and left. So I can take different pictures of the same slide. Now the dice will look different from different angles. Correct. For example, you look here. So this is A, B, and C. Correct. Now this is the same as this. Now I can also have from another dimension, another direction. I can see it like A, B, and D also. Can you feel this? Huh? Can you feel this? If I take it from the bottom, then this is like A, B, and D. Correct. This is also possible. Now, now, how do you find out which which part is opposite to the other part? For example, which of them form opposite pairs? Okay. Now, this is the first way how you find it. So this is when one face is common in two diagrams of a dice. One face is common and we need to find which face is opposite to what other face. Now see how we find this. Very easy method. Okay, you need not see this is adjacent to this that is adjacent to that, nothing. It is a very simple process. What you do, you first find out, yes, hello sir, you first find out the common face. You find out two diagrams which has one common face. Now you look here and here. Now if you look here, so K and K is common in both of them. They have one face in common and the other two faces are different. This you understand. Now if this is so, what you do, you just write it in the clockwise order starting from the common element itself. So now let's see for this one. So I start with K and then I move in clockwise direction. So it becomes KBA. So it becomes KBA. This is correct. KBA. Now the next one. So this is, I again start with K and I go again in clockwise direction. What it becomes? It becomes K M H. This is fine. You first find out the common element. From the common element, you start writing the letters in clockwise direction like this. So it becomes KBA KMH. Now what you do? Whatever is written correspondingly are actually opposite to each other. So here A and H are opposite to each other, B and M are opposite to each other. Understood? Opposite means what? If something is on the top, for example, if A is on the top, then H will be at the bottom. Okay, so this is known as opposite. Now, so what is opposite to H? So A is opposite to H or H is opposite to A, same thing. Similarly, B is opposite to M. This is fine. Now, you look for the first one. So K and K, now this was the common element. Of course, K is not opposite to K. There must be some other letter. So whatever letter remains apart from this, 4 letters are gone and K also. So 5 letters are gone. Whatever remains, that becomes opposite to K. Now, if you look here, which letter is remaining? P is not used till now. This cut this and this becomes P. So that means K is opposite to P. Understood? Now the question was from 2012, it was asking the letter opposite to A. So letter opposite to A becomes what? A is opposite to H. Simple. What is the process? You first mark the common element, then from the common element write everything in clockwise order. Correspondingly they become opposite to each other. Now whichever you see both are there as common, then you have to do what? You have to just write here whatever is the remaining one. Very easy. Now this is for when one face is common in two diagrams. Now next thing is when two faces are common in two diagrams of a dice. Now if two faces are common in two diagrams, what do you do then? So now what you have to do basically, now if you see here 3 is here also, 5 is here also, here also, correct? So this is not one face common, this is actually two faces being common. Now in questions like these, by this diagram you can only tell one thing with confirmation, that whatever are the uncommon faces, so whatever are the uncommon faces, for example 1 here and 6 in this diagram, they will be opposite to each other. That is the only pair you can tell definitely. Otherwise, you cannot tell anything else from this. Understood? So this is when two faces are common, then you can find out. For example, the question was faced opposite to 6, so answer would be 1. This is how simple it is. Now I'll show you many more PYQs. You can do it like this only. Mostly what we try to use this one, correct? That is one face we try to find common in the two diagrams. Why? Because it gives me the solution for the entire thing, correct? The entire dice, all the pairs I will get to know from this process only. Then let's do this. So it says a cube has 6 numbers marked 1 2 3 4 5 6 on its faces. 3 views of the cubes are shown. What is the possible numbers that can exist on the two faces marked A and B respectively on this cube? So what are the possible values of A and B? Yes, good afternoon, Islam. Now, see, first of all, you need to understand one thing. If you see any dice you take, for example, yeah. Now, if you look at this face, what are the other faces that it is touching directly? What are the other faces that it is touching directly? So this face is being touched by it. again this also, the bottom one also, and the side one also. Correct. So that means if I call this phase 1, so phase 1 is not touching only one face. And which is that one face which it is not touching? That is the one opposite to it. Can you feel this? That one is touching all other four except for the one that is opposite to it. That is the only face that it does not touch. Now, whatever it is touching, that can in some position, in some other diagram, from some angle, can become A and B. But what cannot be in place of A and B definitely is something which is opposite to what here? Opposite to 5 here. This is the case that I need to eliminate. Otherwise, everything is possible for A and B. You don't need to see all this rotation, this, that, nothing you have to do. You just have to, because you just have to find out the letter which is opposite to the number which is opposite to 5. That's the only question that I'll eliminate from the option, and I'll get to the answer. Now, how do I find that? So see this. Now let's pick this. So this is 1 is common here, and then 3, 2, and 4, 6. So I write down in clockwise order. So this becomes 1, 4, 6. Correct. This becomes 1, 4, 6. Now this one again in clockwise direction. So what I get? 1, 4, 6. Here what I get? 1, 3, 2. 1, 3, 1, 3, 2. Correct. Now very clearly 6 is opposite to 2, 4 is opposite to 3. Now what is opposite to 1? Of course not 5. So what is it? That is opposite to 1. Opposite to 1 will be whatever is remaining, which is 5. So 1 is opposite to 5. Now if 1 is opposite to 5, what cannot be here in place of A and B? That is 1. So you just cancel out all the options that has 1. So 1 not possible, not possible, not possible. Answer becomes A, 2 and 3. Please remember this concept, that the only face that a face does not touch is the face opposite to it. Okay, little tongue twister, but fine. Okay, then next, what is the symbol? What is the symbol on the face opposite to that containing a single dot? Try to find out. Hello, Abhishek. Opposite to the face. On the face opposite to that containing a single dot. Now, what you do? See here. So basically, again, what you need to find? You are trying to find the two diagrams which has only one thing in common. Okay, this is the same line. Horizontal, vertical does not matter. Just find out those two diagrams and you'll be done. So if you pick first diagram and third diagram, don't you see there is only one common? That is this line. This is 1 dot, 2 dot, 3 dot, 5, 4 dot. Correct? So only one face is common. Now I start writing it like this. So it becomes what? Line. Then after line, what I get to? I get to 2 dot and then 1 dot. Now similarly, I start here. I start writing like this. So it becomes line, then 4 dot, then 3 dot. Correct? This is it. So 1 and 3. Now which is opposite to what? So very clearly you can see that 1 dot is opposite to 3 dot. The question is what is the face opposite to that of the single dot? So against single dot, what you have? 3 dots. So answer becomes B, that is 3 dot. Now this question actually in 2018 had 3 questions. So the other question was, which of the following will be opposite to 2 dots? So 2 dots opposite is what? 4 dot. Then it was which will be opposite to the line. So opposite to the line will be what? Whatever is remaining. What remains? Cross remains. So it will be cross. Very simple. 3 questions were there, just like this. Okay, then yes, Neelam, hello. Then we get to the next concept, which is of open dice. Now, open dice is a very easy concept. So what you have to do here, see, we focus on, see, open dice is what basically this is like, if you have played if you have played with matchsticks. So matchsticks you might have seen, okay, the old ones, the wooden ones, that we used to do what, we used to open all the sides of the matchstick and it used to become something like this. And if you just put it back together, it used to become a cuboid or cube again, correct? So same thing is happening here also. So this is like a dice or a cube that has been opened. Okay, now if you were to close this, if you were to close this dice, which face will be opposite to what is usually asked? Now the process is very simple. See, what you do, you first mark the numbers which are touching most other sides. For example, here 4 is touching 6, 2, 5, 1. All four this is touching. What it is not touching? 4 is not touching 3. Now you have already learned the concept. The only face that a face does not touch is the face opposite to it. So that means 4 is opposite to 3. Correct? Similarly, let's look for 1. So if you look for 1, now 1 is touching 6, 4, 5, 3 very clearly. It is not touching 2. So that means 1 is opposite to 2. Now whatever remains, so what is remaining? 5 and 6 are remaining. So 5 is opposite to 6. The process is very simple. Find the face touching most other faces. And from this you get the opposite for that particular face and then for the entire dice. As simple as this. Okay, understood? Then next is 6 squares are colored front and back. All these colors are there. Now they are hinged together. If they are folded to form a cube, what would be the face opposite to the white face? Now again same process. What you have to do? You have to first mark the letter which is touching most of them. So if you look at Y is touching B, G, W, O, all of these. So Y is not touching R. So that means Y is opposite to R. Now it is asking you against the white face. Now similarly you look for G. G is touching R, B, Y, W. So this cannot be opposite. What is opposite? G and O are opposite. Now whatever remains. So what remains? Black and white remains. It is asking you which is opposite to white. So answer will be C, that is black. Simple. What you were doing, you're just finding out which is touching the most ones. Whatever it is not touching, that becomes opposite to it, and then you can solve the entire case. Okay, then next thing is we get to cubes. Okay, dice is very easy, that thing only. So basically what you have to see, if you have two common faces, one common faces, how you do that. And the other thing was opposite dice, where you try to find out which is common with most of them and then find out the opposite for that, and you will eventually get to solving the entire dice. Okay, now we get to cubes. Okay, now as you can see, this is your beautiful cube. So basically what it has, there are certain terms that you must know. So this is, first is, it has 8 corners. As you can see, there are 8 corners like this. Then it has 12 edges. What is edges? Edges are these lines. How many can you see? 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12. Correct? So how many you can see? You can very clearly see 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. So in total there are 12 edges. This we call edges in terms of cubes. Okay, these lines. Now the last is faces, that you have already understood. That is, how many faces are there in a dice? Similarly, dice is also a cube. So it also has 6 faces. That is, when you consider this is called as a face. Understood? Now a typical question in cube is given like this. So basically what they do, they take a very large cube, okay, and then they cut it into very small cubes. Okay, now they ask you properties of those small cubes. For example, how many small cubes are one side colored, two side colored, like that. Okay, now first thing, let's see this animation and then we'll get to the formulas and everything. Okay, yeah, see this. So basically what is happening here, this is a cube, okay, this is a large cube. Now in this large cube is actually made up of 27 small cubes. Okay, we'll understand how you do small cubes and all. So now it is made up of 27 small cubes, this large cube. Now the thing is that it is red colored entirely. Each small cube is entirely red colored. Okay, from the inside everywhere it is red colored. Now we are putting this big cube that is made up of all small red cubes in this paint. Now what will happen? Let's see. So I put this in this paint. Now what happens? If you see the outside part of the cube turns yellow, of the large cube. Now, but don't you think the inside part will still be red? Correct? Because color is only on the outside. Correct? Inside color may be red still. Now see, if it opens, inside you can still see red, while outside you have yellow. Correct? Now, because of this, what happens? There are different kinds of small cubes that are formed here. See, if you observe, see this particular one. This particular one, can you see it has only one side yellow color? Correct? And let's say I'm just forgetting red for now. I'm only talking about yellow color. Okay, so now how many of them has one face yellow color? One face yellow color, I can see here. Correct? So this is one face yellow color. Now can you see any of them have two face yellow color? Yes. Can you see this? This has two face, one, two yellow color. Can you find more? Yes, I can find this also. This is also two face yellow color. Correct? Then can you see where the small cube which has three face yellow color? Yes, one, two, three. This is three face yellow color. Now the last one. Can you find a small cube which has no side that is yellow color? Can you see it? If you can see, this is the inside one. Right at the inside you have this small cube. It has no side yellow color. Understood? So basically there is one face colored, there is two face colored, there is three face, and there is no face colored. Understood? These are the four kinds of cubes that can form. So in exam they are usually asking you different large cubes, and then they ask you how many small cubes are two face colored, how many small cubes are three face colored, how many small cubes are no face colored. Very easy. Okay, of course you won't have to count and imagine. We'll get to the formulas now. Okay, then yeah, now see this. So first thing, as you saw that large cube, correct, it is being cut into small cubes. Now first question that should come to your mind is how many small cubes will be formed. So that you calculate like this: if a cube is cut into smaller cubes, number of cubes is equals to volume of larger cube upon volume of smaller cube. For example, let's say, remember that cube that you saw there. Let's imagine that all its sides are actually 3 centimeter in length, and of the smaller cubes is 1. Of the larger cube, the side was of 3. So larger cube volume becomes what? 3 into 3 into 3. Correct? And the smaller cube volume is what? Because it has all the sides as 1 1 1. So it becomes 1 into 1 into 1. Answer becomes what? 3 into 3 into 3, that is 27. 27 by 1, 27. So there are 27 small cubes that you can have. Correct? Similarly, if I gave you that, let's say a bigger cube was cut. Okay. Now this cube has side of length 5, and when it was cut into smaller cubes like this, then each small cube had side length 1. Then it becomes what? 5 into 5 into 5, 125 by 1 into 1 into 1, 125 by 1, 125 small cubes. This is the way we calculate number of cubes first of all. Then after this is the value of n. Now n is very important in our formulas. Okay, this is the variable that we'll use in all our formulas. Okay, now first thing, so n is what? N is length of the larger cube side upon length of smaller cube side. For example, in that particular one where you had those 27 small cubes, or 3 into 3 into 3, correct, upon 1 into 1 into 1, that we did, correct. So what is the length of the larger cube side? So length of the larger cube side we had taken 3, and of the smaller cube side was 1. So n came out to be 3. Okay, this you understand. Now using this n, you will understand how we find out formulas for different number of faces being colored. This is n. Then number of cuts we'll understand little later. Okay, now you come here. So this is 3 face colored, 2 face, 1 face, no face. Now first thing, 3 face colored cubes. Now if you remember in the animation, you saw the corner ones. The corner ones like this had a 3 face colored, correct? Now if you look at this, so basically ultimately there is 1 on each corner. So how many cubes are 3 side colored? That is 1 on each corner. Only the corner one will have 3 faces colored, correct? How many corners do you have in a cube? That is 8. So answer is 8. Now this does not depend on the size of the cube, correct? If you take any cube you take, for example, this is also like a cube. Now here also there are exactly 8 corners. If you are looking in the room that you are sitting, if you look around, there also you will see there are 8 corners. So size does not matter here. Always 3 face colored will be 8. Then next is 1 face colored. Okay, before that let's do 2 face colored, easier to see. So now 2 face colored, if you look, so basically 2 face colored, if you remember, it was like this, that is on the edges, 1 2 3 4 5 6 7 8. Now actually how it is going, so it is 2 on each edge, 2 on each edge, 2 on each edge. So it is like 2 on each edge. Now if it is 2 on each edge for this particular, that is 4 cross 4 cross 4. Now the formula becomes important. So basically, don't you think that if it was a bigger cube, ultimately you will just remove the corner ones, and whatever remains in the middle for this particular edge will be 2 side colored, correct? For example, when we had 3 cross 3 cross 3, then we had what? We had removed these 2, and then we had only 1 on each edge, correct? So it works like you just have to remove the corners. Now corners means what? You have to remove 2, correct, from each edge. Now if each edge is of length n, each edge is of length n, n was what? Length of larger cube upon length of smaller cube. So if each of this length is n, then you have to subtract 2. Why? Because you have to remove the corner ones. So it becomes n minus 2 on each edge. Now if it is n minus 2 on each edge, how many edges do you have? You have 12 edges. So formula becomes 12 into n minus 2. Yes, Nandini. Okay, so this becomes 12 into n minus 2. Next is, let's see 1 face colored. Now see this carefully. So basically what we were doing here, again you can feel that the square that is in the middle of each face will be only 1 side colored, that you can feel. Now if you can feel this, what you have to do, you have to make this square that is not at the ends of anything. So basically what I am doing, I am removing the corner ones from here. Okay, this is fine, but I also have to remove corner ones from this side also. So these also need to be removed. Why? Because if you remember, this will be three side color, this will be two side color. What remains is whatever is in the middle. Now ultimately what am I doing? If this whole length is n, I am just subtracting 2 from each side. So ultimately if this length is n, then I am taking n minus 2 here. So this becomes what? N minus 2. Similarly I do it for here also. So this length is also n. Again I have to remove this and this. What remains is n minus 2. So for this particular square, if you can feel, this is the side lengths are n minus 2 and n minus 2. Ultimately what is the area? N minus 2 whole square. So that means on each face it is n minus 2 whole square. On each face, if it is n minus 2 whole square, how many faces do you have? You have 6 faces. So it becomes 6 into n minus 2 whole square. Okay, now if it is this, that is 6 into n minus 2 whole square. Now you get to when no face is colored. Now this you have to imagine a little. So basically what will be the region where no face will be colored? Now what we were doing here, we were from one of the sides we removed. When we are talking about two face color, you got it n minus 2. When you got one face color, you got n minus 2 whole square. When you have no face color, you will get n minus 2 whole cube. Correct? This is how you can remember it. Now why you are getting something like this? So ultimately from each side, that is from the length, breadth and height, you are removing the two corner ones. Correct? So from length you remove, so it becomes n minus 2. Breadth also becomes n minus 2, and the height also becomes n minus 2 by removing the corners. Ultimately you multiply all three of them, what you get is n minus 2 whole square. This is the number of cubes which has no face colored. That is, you remove layers from all the three directions. Understood? These are your 4 formulas. Please try to remember them. Otherwise also, if you have developed imagination from what I have told you, then you will get to the formulas just by thinking only. You don't even have to remember them. Just by thinking you will do 2 removed from the corners, then I have it on each edges, so that is 12 edges and 2 removed from them, so into n minus 2. Similarly you go here and here. Okay, anyway you can remember the formulas if you want. Then now let's get to questions. Questions become very easy after this. Formulas just you have to remember. Now first, this is a 4 cross 4 cross 4 cube. Two face colored. So two face colored, what you have to see, that is on each edge you have to remove the corner ones. Okay, so I remove this and this. Correct? Now how many remain? Only whatever is in the middle remains. So if this whole length is n, I remove one from here and one from here. Now what remain? What I get here? What I get here? I get here n minus 2. Why? Because from n I removed these two corner ones. So this is for one edge, but how many edges do you have? You have 12 edges. So this is n minus 2 on each edge. If you multiply it with 12, you will get 12 into n minus 2. Okay. Then now let's do this question. So a 4 cross 4 cross 4 cube is painted on all sides and cut into 1 cross 1 cross 1 cubes. How many of the small cubes have no red paint on any face? Very easy. Correct? First thing what you find out? First thing what you find out is n. N will be what? N is length of larger side, sorry, length of larger cube upon length of smaller cube. What is the length of larger cube? Of course this is 1, and for the smaller cube it is 1. This is 4 for the larger cube, 1 for the smaller cube. Ultimately n came out to be 4. Now once you get the n, then no red paint on any face. That is no face color, that is n minus 2 whole cube. Now you put 4 here, 4 minus 2, 4 minus 2 whole cube. 4 minus 2 is what? 2, 2 cube is 8. So answer becomes, which has no face painted, 8. Fine. Then next is a solid cube of 3 centimeter painted on all its faces is cut into small cubes of side 1 centimeter. Okay. How many of the small cubes will have exactly 2 faces painted? You do this. I'll wait. Do this. Yes, Shweta, correct. Do it, everyone. It's very easy. Yes, Anurag. Okay. So now it says a solid cube of side 3 centimeter painted on all sides. So basically 1 centimeter is the smaller cube length. So n becomes what? N becomes large cube side upon small cube side, that is 3. Correct. Now once you get this, exactly 2 faces painted. Exactly 2 faces painted. Where you will have this? 2 faces painted, if you remember, on the edges. How many edges? 12 edges. Each edge has n minus 2. Correct. So this comes out to be 12 into n minus 2. I put n is equals to 3 here. So 3 minus 2, 1. So 12 into 1, answer becomes 12. Simple. Okay. Now let's move forward. Yeah, let's do this. A cube has all its faces painted with different colors. It is cut into small cube with side 1/4 of the big cube. How many small cubes have only one face painted? Do it, do it. Yes, Anurag. Four, only one face painted. Four. Yes, Shweta. So first thing what you do, n is length of larger cube and upon length of smaller cube. Now length of larger cube is what? It says that it is cut into smaller cubes with 1/4 the side of the big cube. So whatever is the side length of big cube, 1/4 is the side of the smaller cube. Or in other words, or let's do this. So let's say length of larger side is L, then length of smaller side is what? L by 4. Correct. Now L by 4, 4 will go above, correct, and L and L you can cancel out. So ultimately what you get is 4. So n is equals to 4. If n is equals to 4, it is asking you one face painted. One face painted means what? See, one face painted you used to get by n minus 2 whole square on one face, correct, if you remember. And there are 6 faces like this. So 6 into n minus 2 whole square. So this becomes 6 into 4 minus 2 whole square. That is 6 into 2 square, which is 4. 6 4s are 24. Correct. So this 24 becomes the answer. Understood? Then, yes, Anurag. Do this 2023. Very simple question. Maybe the most simple question that came in 2023. You just have to find out what they are asking. Yes, Neelam. What does this line mean? How many small cubes in this block are surrounded by other cubes on all six sides? Huh? Surrounded by other cubes on all six sides. This actually means no face colored. Why? Because if it is surrounded by cubes from all other sides, then when you dip it, if you remember that example, it will not get any color. Correct? If you see here, what you saw in this diagram, which were the ones that were not colored from any sides, which was inside or covered on all the three sides. So that is what it is asking. It is asking you how many small cubes in this block are surrounded by other cubes on all six sides. So ultimately this is no face color. So answer becomes n minus 2 whole cube. Now this is 5 into 5 into 5 and it is cut into 125 identical blocks. That means what? That means what? If you remember, number of small cubes was equals to volume of larger cube upon volume of smaller cubes. Now volume of larger cube is very clearly given, 5 into 5 into 5, and this I don't know, okay, but I do know this, which is number of smaller cubes. So this becomes 125. 5 into 5 into 5 is again 125 upon question mark. Very easily you get the value of question mark is 1 itself. Now how can you get 1? How can you get 1? That means the cube could have been 1 into 1 into 1. This was the size of the small cube. Of course you don't have to do all this calculation, you can see directly that there are 125 identical cubes. It is 5 into 5 into 5, so that means it will be what? 1 side length cube, the smaller one. So now n becomes equals to what? N is larger cube side upon smaller cube side. So that means this is 5 by 1. N is equals to 5. You put 5 here. It becomes what? It becomes 5 minus 2 whole cube. 5 minus 2 is 3. 3 cube is 27. Answer is A, 27. Understood? Simple? Yes. Yes, Neelam. Yes, Shweta. Okay, then. Yeah. Before this, now let's understand what we left here, which is number of cuts. Now see. So basically, this is number of cuts. Now, this is a line here. I ask you to divide this line into four equal parts. This is the line, okay? This is the line. I ask you to divide it into four equal parts. Now, how many cuts you will have to make? If you have scissors, how many cuts you'll have to make? You'll have to make 1, 2, 3 cuts. Can you see it getting divided into four parts? Yes, 1, 2, 3, 4 parts. How many cuts you made? You made only 3 cuts. Similarly, if there is a longer line, let's say this, I ask you to cut it into 5 parts. 5 parts. Now, how many lines you need? 1, 2, 3, 4. Can you see 5 parts? Yes, 1, 2, 3, 4, 5. So that number of cuts is equals to number of parts that you would want minus 1. This is clear? Correct. So if I wanted 4 cuts, I had to make number of parts that I wanted was 4. I had to make 4 minus 1, that is 3 cuts. This you understand? Now, if this is what you do in a single dimension. Now, if you consider 3 dimensions, Then what you have to do, for example, for a cube, you have to consider all the three sides separately. All the three dimensions you consider separately for length, breadth, and height, and you will get the answer. For example, if the question says that a large cube is cut into 216 small cubes, then what you are essentially doing is 216 small cubes. This you can write like 6 into 6 into 6, correct? Now, from each of them, now to make 6 cuts in the vertical direction, sorry, to make 6 parts in the vertical direction, how many cuts you have to make? So this is parts, correct? So to divide it into 6 parts in the vertical direction, how many cuts? Just -1. So you need 5 cuts in the vertical direction. Similarly, in the horizontal direction, 6 minus 1, 5 cuts here, and in the direction of the height. Okay. How many cuts you'll have to make? 6 minus 1, 5. So ultimately, how many cuts do you need? You need only 15 cuts to divide a large cube into 216 small cubes. What is the pattern? You take this number, correct, then you write it in this form, that is in multiplication of 3. Okay, so you divide it into this into this into this, a into b into c form. After that, what you have to do, you have to just subtract 1 from each of them, and you will get the answer. That is it. This is how you add, and it will usually ask you the number of cuts required to make 216 small cubes of 1 centimeter, of 1 cross 1 cross 1 each, and this is how you do this. Now let's see this. Yeah, so it is saying what is the least number of cuts required to cut a cube into 64 smaller pieces. Try to do it. First thing what you will do, 64, you will try to divide it into almost equal parts. We always try for almost equal. Okay, now in this case, equal is also possible. So you try to divide it into almost equal parts. That gives you the minimum cuts. This is very clearly divided as 64. Just by seeing it, you remember that this is 4 into 4 into 4. Correct? Now how many cuts do you need? Just one less from each of them. Correct? So this becomes 4 minus 1, 3 cuts. This is also 4 minus 1, 3 cuts. This is also 4 minus 1, 3 cuts. You add all 3 of them, 3 plus 3 plus 3. How many cuts? 9 cuts is what you will need. Answer becomes B. Simple. Okay. So this is how you usually do it, that you just write it like this. It is cube of what? And then just -1, -1, -1. Understood? So this was the last thing that we had to learn, that was number of cuts. With this, we are done with our lecture on dices and cubes. Okay. Sorry for the delay today. We'll make sure that the delay is not there. Still there was power cut. Yeah. That's it. Hope you like the lecture. Thank you. Yes, Nandini. Yes, Neelam. Yes, Anurag. Yes, Shweta. All correct.